Hello. Central, congrats on the first. Jed, hey, you scared me. YouTube's up. All right. First things first, let's clean up this PDF. Or not PDF. What are those things called? Hey, Rapture. Buys? Let me help. What? Are you unscaring me? Oh, bees. Oh, boobies. There we go. I was very confused there. Please no more epsilon delta. Ugh, I'll keep this page here, but I don't want to look at it. That page can stay. Okay. We're organized. I'm going to start off with some linear algebra. I was looking around randomly. I found this. Is it a textbook? Sure looks like one. Oh, yeah, it is. I have had enough ED in my life. Yes, Jed. I don't want any form of ED in my life. Only they made a pill that would address epsilon delta proofs, though. Um, keep your $8. Wait. Oh, what? There's only two problems, but a bunch of exercises. Okay. I'm just going to take some of these systems and do my own thing with them. Was my plan. Let's start with number 3, I guess. Okay, so I want to solve the system in a particular way that I haven't seen before. We start off something I have seen before, which is an augmented matrix. Well, no, we won't even do that. Yeah, we were saying yesterday that I'm Neo, right? It's only natural that I should study the matrix. Oh, Cytos, that sounds terrible. I want to solve this using the null space. And so I want to consider the homogeneous system. Which is very similar, but slightly different. Wait, well, how exactly do I want to do this? It's just, yeah, just saying consider it. I don't have to do anything with it, just consider it. Consider that considered. Now, there's more to the question than the source where I got it from. I just want to do my own thing with the problem, though. Actually, if this only has one solution, null space is going to be 0. let's just let's go through it anyway. Let's not worry about homogeneous yet. Let's just get this into at least upper triangular form. Like an echelon form. So I tried to watch it, but I had this problem with quite a few websites that use dark mode. It just makes me feel sick. And the black background with things moving in that part particular like the very first video in 3 Blue 1 Brown's series of Boolean algebra videos just makes me feel sick. Like I have to barf. So I've seen about 10 seconds of it. I've been watching lectures from Gilbert String and the MIT OpenCourseWare stuff. One minus -2 is 3. Okay. The good old Boston Strangler? Is that what he's known as? Yeah, how did this one get here? Did it? Shouldn't it be 3? What is 5? See, Saito, even you messed it up. Never heard him called that while I was there. I also didn't take his class. His lectures are really good. He does some things that I think I would find really confusing if I was doing this for the first time. Like, he started off his very first lecture by saying that vectors are going to be in bold, but he's writing on a chalkboard and he's trying to write quickly. So immediately after that, every other time, he just does a normal X. And it's like that. I would get really stuck on that and be lost in his lectures trying to figure out what's a vector and what's a scalar if I was taking this for the first time. But aside from some like small things like that, I really like the way that he explains things. I'm thinking about it, Jet. I'm not sure yet. I wanted to get the null space of this. The normal way that I would solve this, I would just do what you say, but I want to consider the homogeneous version of this system. And I want to solve that, but like I may as well solve this thing at the same time. My timing is perfect. Famished? Why is that? Post a problem math discussion. Oh, okay. Okay, so I'm getting the only solution here is zeros. So the null space is just. Ugh, okay, this isn't the example that I wanted. I want infinitely many solutions. Let's look at Famish question. Oh. Famished, you have impeccable timing too. Because look at this question. Although we're not going to use matrices. I assume that you're not learning about those. So they're telling us to eliminate z. So I looked down this column of z's, and I think I want them all to be the same. I want them all to have the same coefficient. We've got a 3, we've got a 1, and we've got a 4. I want to multiply each of these three equations through by something to get them all to have the same coefficient for z. So I think the most convenient choice is 12 because, or I want to get 12 as the coefficients for all of these because 3 times 4 is 12, and I don't think there's a smaller number that works better. Oh. Cytos, that's a much better observation. I mean, we still need a second equation. You know what? Yeah, what I'm saying is too complicated, though. I am making it too complicated. We don't need to go all the way up to 12, because 12 is annoying. It worked. But let's follow what Cytos is suggesting here. Let's add all three of these equations. How about A and B first, then B and C? We can do that too, yeah. Let's do it that way then, so that's the way that you're doing. So if we consider just A and B, let's make the coefficients for Z match. So that has a 3, that has a 1. So I'm gonna we're gonna want to take equation B and multiply 3 by 3. So A is just gonna stay as is. Now we'll do 3 times B. So 9x minus 3y plus 3z equals minus 3. So now for elimination, we have a plus 3z and a plus 3z, so we want to subtract these two equations. And the thing to be careful of is that this minus sign gets distributed to each of these terms here. So it's x minus 9x is negative 8x. 2y minus negative 3y is like 2y plus 5y. Right, sorry, 2y plus 3y is 5y. 3z minus 3z is 0, as we engineered it to be. 1 minus negative 3 is positive 4. Great. So that's one equation with two unknowns. So we need a second equation in order to solve that, and that's where B and C come into the picture. For the sign distributes, yeah, that's always the trick with these. Like, or it's really easy mistake to make. So if that's your mistake, then awesome. I'll keep going through and solving the system. But if that's all you needed to hear, then feel free to not pay attention if you don't want to. But I will go through and solve it anyway. So looking at B and C, we have 1z and negative 4z. So I care more about the 4 than the negative or positive. So let's take equation B, multiply it through by 4. Then C will stay as is. Now we notice that the z's have the same coefficient but opposite signs, so we're going to add them instead. And that's a little bit easier because now we don't have to worry. We don't have to remember to distribute things. So 12x plus 2x is 14x. Negative 4y plus negative 3y is negative 7y. These plus and minus 4z's cancel. Then negative 4 plus 4 is 0. Nice. So we can keep going on the substitution train. Sorry, on the elimination train. I feel like substitution is a little bit easier here, though. Sorry, I should point out, we now have two equations and two unknowns. we've given ourselves a simpler problem that we can solve that for x and y, and then at the very end, at the very end, we can go back and get z. I noticed this second equation is relatively simple though. Like in my mind, I just want to solve it for x and y and plug it into the other one that's a little more complicated. Okay, so I guess let's go through it. This second equation, we can make it 14x equals 7y if we add the 7y to each side, and then divide each side through by 7 to get 2x equals y. So this is a relatively straightforward thing that we could substitute. We could do this with elimination too. If you'd rather see that, let me know. But I think substitution is easier for this exact reason here. We just get that. So if we know that y is equal to 2x, substitution is fine? Okay. If we know that y is equal to 2x, let's plug it in for that y right there and figure out what x is. So that's a terrible arrow. Dude. Okay, I'm redrawing it. This arrow is extremely important to me, evidently. So negative 8x plus 5. Now y is actually 2x is equal to 4. Solve this for x. Minus 8x plus 10x is 4. Negative 8x plus 10x is 2x equals 4. Divide each side by 2 and we get x equals 2. Great. Now we just move back through our equations and get y and z. So y is 2x. So if x equals 2, then y equals 2 times 2. So y is 4. Now we can choose any of our 3 original equations to get z from. Yeah, 3 variables is definitely trickier than 2. You have to do a lot more work, and there's a lot more opportunity to make like small mistakes. Equation B looks like it has the smallest numbers to my eyes, so let's use equation B to find z. So 3x minus y plus z is minus 1. X equals 2, so 3 times 2 minus y is 4, plus z is negative 1. So that's 6 minus 4 plus z is minus 1. 2 plus z is minus 1. Z is then minus 3. And so this, so the solution we would say is like the 0.24 minus 3, basically, for x, y, and z. And that's just our answer there. This same like set of numbers should work for all 3 of these equations, and I'm sure if you plug them in, they all should. I mean, I can still find a way to screw up the Gaussian elimination stuff mega, but yeah. So I hope that helps, Hamish. Let me know if you have any questions about what I did or anything else. Matrices next. Oh, nice. So yeah, I mean, I don't want to like overload you, but what you'll discover is that this exact same system can be written with matrices. This one would look like 1, 2, 3, 3 minus 1, 1, 2 minus 3 minus 4 as a matrix times a vector, x, y, z of our variables, equals a vector of whatever's on the right side. But if you don't understand this yet, I wouldn't worry about it, but it's a pretty neat thing that this crazy looking matrix equation turns out to be the exact same thing as this. The first two steps are tricky? Yeah, fair enough. No worries, famished. In schools, I'm about 14, 15. Yeah, only cover matrices during undergrad. Same, Jasu. It's weird. All right, I see. Penguin posted a question in the Discord. Let's see if we can answer it. As well as the solution. You dropped out of high school. Oh, okay. So Penguin, I'm not sure if you're here. You only posted this 10 minutes ago, so I hope you are. Let's read through it though. What? Oh, I misread this. Okay, so this statement here means that g of x is the inverse of f. Okay. I'm not looking at the solution yet. Maybe I should delete it, but actually, let's just shove it off to the bottom for now. Just so I can think about it first. So they're asking us about g of 7. And so if f of x equals y, then f inverse of y equals x. So if they're asking about g of 7, they're asking, I guess, basically what value of x gives you 7 in your original f of x. Now that's probably going to be a little too hard to solve by hand. Barely doesn't group. That's mean. Hey, syntax, logarithmic derivative? I don't think you need a logarithmic derivative. Or maybe you do. I haven't gotten that far yet. All right, so there is a formula for the derivative of the inverse of a function, but I don't know. Do they actually expect us to solve this? I guess 1 is a natural thing to guess for x. By guessing. Just take the derivative of that? Oh, okay. Oh, yeah, for that thing. Or for like the formula for the derivative of an inverse. Yeah, I mean, I think it's not immediately helpful to know this formula until we know how to express. I mean, if we know that g of 7 is just equal to 1. No, we still need. No, you're right. We still do need that formula. All right, so yeah. Using chain rule, we get this. I mean, I've done this bit before. Don't we want to get rid of the composition, though? How does that work? Or do you not care about it? We should care about it, right? Oh, I see. Yeah, that's what you're saying, Mega. So yeah, if you let x equals 1, you get that g prime of 7, because f of 1 equals 7. Is equal to 1 over f prime of 1. And we can find f prime relatively easily. We already know that the g of 7 up here is just 1. So we only really need to find g prime of 7, and we just found a convenient form to find g prime of 7. So let's find f prime of 1 and do 1 over that. Prime 1 is then 14. So g prime of 7 is then 1 over 14. So then g of 7 over g prime 7 is 1 over 14 equals 14. Noish. So they do the same. They solve this thing by guessing, also, it seems, which is kind of mean. I guess they made it an easy guess. Oh, that's true, Saito. So you could always use the rational root theorem. I forgot about that. Yeah, Mega. So I don't know. I haven't seen Penguin type anything. I forget what their. I think they were on YouTube. What their username is, but I see that Saito's here. Type it in that post as well. So wait, what was the first natural question? Understand the solution, unable to connect between the steps and find the hint in question. Ensure the first derivative function is strictly increasing. Yeah, always positive, sure. Oh, so it's gonna be one of those cubics. Or quintics. Um, see if the person types anything back. But for now, we might go back to linear algebra studying. Oh yeah, so this example turned out to not be that great for what I wanted to do. Wait, rational root theorem would give you 6 choices. Because you have to subtract the 7 over. Like, you would have to check the factors of 6. I guess, no, you get 8. No worries. Either way, you're right. 1 is a pretty easy guess. But I definitely never think, I definitely don't usually think of trying to guess solutions, and I think most students don't. So, um, okay, I want a different system of equations. I want one with infinitely many solutions. You know, I wouldn't mind doing this problem as it's stated too. Necessarily. Let's just... do any of these look dependent? That's what I'm really after. I don't see any dependence. Surely they give us one. With infinite solutions, right? Like, you can't really have a complete problem set if you don't have that. All right, fine. Let's just find the null space of that. That'll tell us whether we have a shot at infinitely many solutions or not. These seem pretty independent to me, to be honest. Hey, Chirag? Chirag? I'm sorry if I'm saying that wrong, but I'm not a teacher by profession, though. I am a tutor. Like that? This is independent, man. Stop it. I want to be dependent. Okay, like what I want to do is that you can find the if a system has infinitely many solutions, you can find it you can express it as the sum of a particular solution plus the null space. And I was interested in trying to do that myself just so I can get to know it better, but This isn't it. Make sure it says full rank, its null space is 0. Yes. You need some free variables to have a null space, I think. Or actually, let me see if I can... Let me see how much I've absorbed from these lectures. The dimension of the null space of some matrix A is equal to the number of columns. A is m by n minus the rank. So yes, you do need, or if it's full rank, I mean, I guess full column rank, its null is 0. You might not even need full rank. If it's... Hey, Vivon. How's it going? If you have extra rows, that happens to your null space. I don't think your null space gets bigger. I think you just make it harder to have a null space besides the 0 vector. Hey, Solenia. Nothing much. How about you? All right, maybe we should make up an example. I'm so bad at making up random numbers. Why am I... Don't do 4 dimensions. I want 4 columns. So I'm specifically summing these 2 columns for the third one, but I'm going to change the third result just to make sure it's independent. So that will be a -2. Let's make it -1 then. And actually, just for funsies, let's swap the negatives also. Okay. So I suppose we're going to do our row operations and get it upper triangular, or as close to upper triangular as we can. These numbers are quickly getting disgusting. This is why you don't make up your own linear algebra problems. Oh, God. What did I do to myself? 5 and 16? Well, no, I mean, we should use row 2. Okay, I mean... Ugh. So it becomes plus 16 minus 17 is -1. Hey, that brought it back. Oh, this is getting right back to being disgusting, though. Never mind. Okay, so we have 3 pivots and 4 columns. I expect my null space to have dimension 1 based off this. Because it's always, the null space is the same as the number of free variables you have, and we're going to have 1 free variable because of that column. Whereas these are all pivots. So how do I actually find the null space now? How is he doing it? It's everything that sends this to be 0. So do we bring it back to a system? That might help me think about it. Oh, right. I remember now. Um, you can find the null space systematically by letting one of your free variables equal 1 and all the other free variables equaling 0. Academy of Useless Ideas, welcome in. Thank you so much for the raid. I was lurking on you a bit. Hope your stream went well. Hey, Fembucks. For anyone who's new here, I'm Dom. I do some actual math sometimes. Just for my own like setting, I've been doing some linear algebra. So I'm currently practicing just with like the null space and how it relates to the solutions to a system of equations. Hey, Sereno, meme with null space, Drake bad, and good Drake for kernel. What? Oh. Like the Drake meme where like in one he's like that and then the other one he's like that or whatever. Yeah. I mean the kernel I don't actually even I've heard of kernel before. I forget what it actually is though. Yeah, I hope your stream went well. For anyone who's here on my MPC, check out Academy of Useless Ideas. He's a very like entertaining stream. In terms of like the story of math. The kernel is the null space, really? Why does it have a different name? Oh. Did it have improvised karaoke? Oh, I heard you talking about that. Yeah. Oh, nice. Will I do karaoke? In theory, yes, but today would be a bad day for it. I've been struggling with losing my voice. It's kind of teetering on the edge right now, so I probably shouldn't push it by trying to sing. Don and Slim duo would be great. We can make that happen. When my voice is feeling better. Beatboxing? Oh my god. I don't know how to beatbox, so I feel like I make my voice even worse. But like I've seen like videos of people who are really good beatboxers, and the stuff they can do is crazy. Like, it's apparently like you can make 3 different sounds at once if you learn how to use each like separate part of your like throat. That's what she said. Or like that, there's like some crazy things. Oh, do you play Factorio? I have a run going. I'm just it's pretty badly neglected because I just keep playing other games and I haven't had time for it. Hey Lucas, how are we to be in math? You'll be trash. Same. Hey lyrics. Well, welcome in. Yeah, I've been studying some linear algebra. Trying to like speed run through some lectures to remember the things that I learned before. And I didn't learn it by name, but I'm trying to get more accustomed to thinking about the null space. Um, and so what I'm trying to achieve is in a lecture that I watched, the person, Gilbert Strang, expressed a solution to a system of equations as the sum of a particular plus the linear combination of the homogeneous. And I'm trying to get an example where I can do that same thing. The examples I'm seeing online are not what I want. But I thought this was kind of neat because you do the exact same thing with differential equations. Math is an art form? Yeah. The better you get at math, the faster you realize that you're trash. Yeah. So yeah, I've been watching his like MIT lectures and been learning a lot. Like, yeah, I know that linear algebra and differential equations have a bunch of like crossover. I learned about it even. I just am so rusty on it. Oh yeah, I know there's a reading group, I think, happening right now on Friedberg. I think it's a little bit too advanced for me, but I'm glad that it's happening. And hopefully I can get there. But once I relearn the basics of linear algebra, I'm thinking that I should try and study a little bit more advanced. Friedberg is tough, string is good. Okay. I haven't tracked down any of String's books. I have offhand linear algebra done right. And another one I can't remember. But by Friedberg and some Spence is more abstract. Yeah, I want to get some abstraction. I prefer applied math in general, but I feel like it's good to know at least a bit more abstracted linear algebra than I currently know. Sonia, I guess what am I currently studying? I guess there's a couple ways to interpret that question. Right now, I'm not a student. I'm applying to grad school, but I'm just studying things for fun. So I've been going, but the most recent thing I've been studying is linear algebra. Other than that, the only thing I'm really actively, well, I'm taking Zach's infinite series course, and then I'm also studying physics. Linear algebra done right is good before Friedberg. Oh, nice. I've applied for both PhDs and masters. My immediate goal is more of a master's, but I just kind of upgraded my applications to PhDs for some of them just because they'll usually accept you for a master's if they don't want you for a PhD. Hey, Papadoria, it's going well. Thanks for asking. Looks like you got a combinatorics question. How are you doing, Papadoria? And for anyone new around here, I dual stream to Twitch and YouTube, so And Papadori is over in the YouTube chat. Rex, and sorry, I saw your message and I forgot to say hi. I don't know. I know it's possible to see your percentage. I feel like I'm getting towards the end of the base game. I have one more Dreamer left to beat. And then I don't know what happens after that, but I assume that's pretty close to the end of the game, if not the end. But I need to explore and get some more abilities before I can do that. So I guess like 80 is my guess, but I don't know what my actual percentage is. Great, you actually really knew Combinatorics might be an easy one. I think it might be. But I haven't read it yet completely. Hubbard and Hubbard, vector calculus, linear algebra, differential forms. Oh, interesting. I'll write that down, and I have special skills when it comes to finding textbooks. Linear Algebra 5th edition by Friedberg. Let me write that down too. Oh, null spaces, dual spaces, etc. Okay, nice. Oh, that's right. It is different in different countries. In America, you don't need a master's to get a PhD. It helps, but you don't actually need one. You go straight from bachelor's to a PhD program. In the first 2 years of a PhD program are basically you getting your master's. But master, if you're just a master's student, you don't have to pay tuition. If you're a PhD student, you normally are funded and you get paid. So if you can get into a PhD program, it's really advantageous, even if you stop at the master's. You regret not knowing basic functional analysis for a graduate. Fair enough. I should say I'm going for applied math in particular, but functional analysis might still be a helpful thing. I don't know anything about it. Ooh, Cytos. I remember seeing Zach just doing a similar problem as that. I might be able to figure that one out. Okay, let's read through this problem on the screen. Who needs applications? Me. I love applications. 10 people are to be divided into 3 committees in such a way that every committee must have at least 1 member. No person can serve on all 3 committees. How many ways can this be done? I do think this is relatively basic, but I'm not very good at combinatorics, so let's see if we can puzzle this out. Wait, so people can serve on 2 committees? Oh, that actually, this isn't that basic, I don't think. This is a little... Huh. This might feel like one where it's... Yeah, exactly, Papador, you have the same stumbling block. This feels like one where you get the total number of arrangements and then subtract off the ones you don't want. Yeah, I did take 1 semester of linear algebra during my bachelor's. It was very computation focused and not very theoretical, I would say, though. 10 bucks is column 7 to the 10 minus 1. Multinomial coefficient. I've heard of that. I don't remember what it is. You think you're answering too quickly? Yeah, like, so we have to divide up all 10 people, right? Yeah, I think someone could be on 2 committees, but not 3 committees, which is, if we just make it so 1 person, 1 committee, we could maybe solve that problem and get an idea for the real problem. Um, I I I I assume each person does have to be in a committee. You have to assign all 10 people somewhere. That's my assumption from the wording, at least, Looper. Is it k equals 1 to... No, this isn't quite right. Definitely into Clifford algebras. I've heard of Clifford algebras before. I remember like Dr. Cook, when he was streaming, was talking about them, and he's like a physics professor. That's a good shout, lyrics. Thank you. What I wrote here isn't right, by the way. I was thinking just put a 3 in front of whatever sum I can make here, but I think the sum is wrong. Okay, I thought this question was gonna be basic, but it definitely does not seem basic now. um, yeah, if you have to divide up the 10 people into committees, that's what makes me think you have to assign all 10 people. So I guess you could have 118, 127, and like all of these things. Papadori problems are never basic. Yeah, Fembox, that's true. Papadori was literally given the Colette's conjecture, so... Hey, Fizzbuzz, Dr. Cook is cracked, yeah. Can I do trig proof such identities, Garbo? Yeah, sure. Feel free to let me know. If there's a really like crazy or complicated one, I might have some trouble with it, but like in general, I can, yeah. Feel free to type it out there in chat, or if a screenshot is easier, I have a Discord. Actually, no, that's not even true. Since people can serve on 2 committees, that oh my god, there's so many things to count. Rather question I get asked when you get introduced to a topic of combinatorics, or I know this is not a good introduction. Hey, is that an I or I think it's an I? Monai? I think so, yeah. That's how I'm interpreting it. So if everyone serves on 2 committees, does that mean that these rows would sum to 20? So you could have 2, 2, and... No, no, no. Wait. That can't be true. Look at people individually. See how many possibilities there are for one person. Okay, I think we're gonna do Garbo's question quickly. Garbo wants to prove a trig identity, so let's see if we can quickly do this one, and then we'll return to combinatorics. I think maybe Cytos, you have the right approach, or at least that sounds like a better approach than what I'm thinking. Papadoria is suggesting to express one of these with a Pythagorean identity, which seems like a good idea. Oh, yeah, you can immediately take that cosine squared to be 1 minus sine squared. Okay. Both of them are cosine 2x. Yeah, my mind went to the doubling was at first. Yeah, Papadoria is smart. Look at the people individually and see how many possibilities there are from one person. I mean, you can choose one or two of the committees, I guess. There's no maximum, right? You could have all 10 people on one committee. And then like 5 and 5, I guess is valid, right? So could it be all the ways to sum to make three numbers sum to 20 and the maximum, those each of those numbers have to be minimum 1 and maximum 10? Someone can just not serve on any of the committees. I was interpreting, we're taking the 10 people and we're dividing them into three committees. I think everyone has to be on a committee. That's my interpretation of the wording. Because otherwise, why would you phrase it like that in the first piece? That's what I think too, Papadoria. Find a number that goes against the Collette's conjecture. Infinity. I don't know. Just a partition, they wouldn't say that nobody could serve on all three committees. Hmm. Can we just clone the 10 people, try to count the ways to divvy 20 people into three separate committees? Ooh. That's a thought. Yeah, and Papadoria agrees this question could be more clearly stated, but it's the one that they have to answer. So we just got to do our best here. So it's not. Is that cloning idea the exact same as having the same person serve on two committees? No, it's not the exact same, right? Because we can't allow 1-1-18, right? That seems like a problem. Right, so I'm saying it's a problem because like um no, I don't know. Maybe it's not a problem. I'm having a hard time evaluating that idea. It seems clever if it works. Lyrics prove that trig identity with differential equations. That might be the most extra way to prove that ever. Fair enough, though. Using a bazooka to break a piece of wood. By the way, just because I've seen a few new faces in chat today, feel like I should take the opportunity to shout out that there's more math streamers on Twitch than just me. Um, if anyone hasn't seen this list of people before and you're interested in math streams in general, there's a whole list of people there who all do math help like me. In addition to Academy of, well, Academy of Useful Ideas, I don't think that does like math help quite like this, but he is another awesome math streamer. Selenia, I think yes. I think every person has to be in a committee. Prove doubling identity is pretty simple with Euler's identity. I've heard that, yeah. I haven't looked at it for myself. Help me prove the Riemann hypothesis. The answer is 3. But you're the best one? Oh, I'm certainly not the best one. All right, this might be a Googler. Oh, I don't know where these are coming from. In our class, we're all about bazookas. So this is basically the same problem for 3n plus 1 people. And okay, yeah, so if n equals 3, we have our situation, right? Assuming the committees are distinguishable, I didn't even think about that. Wow. Each person has 6 choices. Oh, okay, this is like what Sidos was saying to start with. Like, looking at it from one individual's perspective. You can choose one of three committees or from one of the three pairs. But we have to subtract off any scenarios where any committee is empty, because we don't want those. Oh, so this is nearly what Fenbox said. I think I prefer the 6 to the power thing, but yeah. So here 3n plus 1 for us is 10. So 6 to the 10 minus 3 times 3 to the 10, so 3 to the 11. Plus 3. So 6 to the 3n plus 1 is the total number of arrangements before we account for some committees being empty. Yeah, they even link to it here. Yeah. And so what is this subtraction? How do we arrive at that subtraction? Oh, okay. They also mentioned the assumption that each person does have to participate somewhere. Wait, but even what I know that n equals 3 for us, but like I'm trying to figure out what this piece means, like in our case or in 3n plus 1. I know what it should be, but I'm trying to figure out why. Three to the n plus 1. Yeah, it should be the case where a committee is empty, but presumably it's overcounting, because then we do this extra thing here. Wait, why is 1 raised to the power of 3n plus 1? It seems a little pointless now that I really think about it, but giving each person a binary number 0 to 7. 7 is results because they can't serve on all three. Oh, interesting with binary, to be able to represent someone serving on 2 committees. Or stars and bars? I know I've heard that. Zero 1 0 is just committee 2. Interesting. I don't know how we use that, but that feels like it'd be helpful. I'm sure there's a reason, or I still can't figure out the justification for how exactly this other piece represents some committees being empty. Okay, well, let me try your binary idea. So if you write out the 3-digit binary numbers, we can't allow you, and we can't allow you. I assume that's something from how the inclusion and exclusion principles represented on the Wikipedia page, Papadoria. I'm weirded out by that too, though, with why you have the 1 to a power. So, as far as I get from this Finbox is that each person has 6 choices, and so before we account for the committee's requirements, there's 6. Wow, that's not 6. There's 6 to the 10 arrangements for these 10 people. But the thing that I still don't know is how we do account for each committee having at least 1 member requirement. If you look at the first column, 3 of those 6 ways don't cover the first committee. Sure. And I guess there's 3 of the ways for the second committee and 3 of the ways for the third. Oh, so that's why it's 3 times. So there are 3 to the 10 ways. No one covered that one. And then you multiply it by 3 because then there's 2 others. Huh. But yeah, then we have to add 3 somewhere, as Lyrics is pointing out. So one of these ways is okay for some reason. Last term counts the case where 2 committees are left open. The last term counts the case where 2 committees are left open, which should be overcounted. And there's 3 ways to leave 2 committees open. How many times did we count it? We counted that 3 times. I feel like it should be 2. I know I'm wrong, but we still want to include one of them, right? Or wait. No! We counted 6 ways and we only want 3 of them, right? Because we counted the ways committee 1 could be left open, but that also included committees 2 and 3 being left open. And then in committee 2, similarly, we also counted committee 3 being open and committee 1 being open at the same time. And then in committee we double counted each of them, and we only want, there's 6 of those scenarios, but we only want 3 of them because 3 of them are duplicates. Okay. So, the explanation for each of these terms. We have 6 of the 10 total arrangements. Remove a committee not being covered. Three committees that might not be covered. Hey, SimplyFX. In this one, okay. Sounds good, Papadoria. Dang, Tuffy. I'll put the link to this thread in both chats here. Oh, what is this? I just scrolled down in that thread just to see. This is this feels like using a differential equation to prove a trig identity. Oh my god. Oh, you can get a little factorization for that? Nice. There's probably a different interpretation that you could do with that, like factorization also, I bet. Okay. Was I doing before? I was still working the null space of this thing. I think I want to find the null space. Differential equation to prove a trig identity, or else we get a tautology. Stranging it up. So I believe that the technique string used is for each free variable you have, which in this case we only have one, assign one of those free variables to be 1, the other ones to be 0, and see what the other things are. Or see what the other variables have to be. So we'll just let x4 be 1 and see what this must be. Whatever we get, it will be multiplied by a constant, c. So if x4 is 1, then x3 is minus 22. Volterra's function. I've heard of log of Volterra. I don't know Volterra's function. It's differentiable. The derivative is bounded. The derivative is not Riemann integrable? You can take the derivative, but not the integral? Hey, Phobos. Hey, Zappin. You both are doing well. That seems weird. It's a function that fails the second fundamental theorem of calculus. Yeah, I guess so. I never heard of this thing. Okay, it would make sense it's a function that's like this that would break it. Hey, Freddy. I never knew a function like this existed. You can take the derivative, but you can't integrate the derivative to get it back. Wait, what's it calling fat? You can have a fat Cantor set? Sounds kind of mean. Classical electromechanics like Faraday's laws? Sort of, yeah. Like, if you have a question, I'll definitely try with it. Maxwell's laws? Yeah, I have learned them. I'm not, like, the absolute best with them, but you can try me. Plan helping my sister learn all math up to pre-calc. Be the hardest part. I mean, I don't know your sister. How am I supposed to answer that? uh, hmm. Like I mean, it's like a personal thing, I guess. What people find difficult or not. So you're saying conic sequences in series, functions, basic geometry. I mean, maybe sequences in series. I don't really. I have a hard time answering that. What does the nabla and dot symbol mean in the tabla and products? Wait, what is tabla? Oh, I mean, it's just a typo. Damn it, Google. Um, yeah, if you haven't done vector calc, you're gonna have a very difficult time with these equations. I gotta say. So, we should really rewrite these with the symbols that you're asking about. Let me get a screenshot. So this is a different notation for the thing that you're talking about. So curl of E is the same as del, or nabla, I believe, dot E to minus dB dt del dot B is mu naught epsilon naught dE dt is mu naught J. Divergence is Nabla's the name of the symbol, del's what we call the operator. Oh, really? Wait, am I mixing up? No, I'm sorry. Curl is cross. Curl is cross. Cross, 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 cross. Cross, cross. Right? Because divergence is dot. Divergence is a scalar. Curl is a vector, I believe. Zero. Okay. Divergence is a state of mind. Through true meditation, you too can achieve divergence. Curl across divergence dot. Okay. If you want to cry, watch this video. What is that? Lyrics. Oh, and geometric clever algebra. Maxwell equation applies to one equation? Oh, that's crazy. All right, so the magnetic flux density cannot be created on its own, must be sent as a result of moving charges which are induced. For instance, the expansion of the vector field. Yeah, actually, maybe I should go to the book because they have a nice like visual explanation of what these things are. Getting into the calculus of it is more than I am really equipped to do offhand, but where was this part of the book? Here we go. So divergence, as you're saying, right, it's like the vector field expanding or contracting in some way. So in this one, B, you would say this one is going to have a positive divergence, I believe, because if you look right in the middle here, it's like there's a source of something that's producing the vector field. Like you could draw a box around here, and there's a net sort of flux out through that box. Hey, Zeliox? What is a complex number? Yeah, I absolutely can. Let me get through this little bit here, and I can talk about complex numbers. In curl, and yeah, as Ray says, the divergence for B has to be 0 because like a monopole can't exist. I'm just repeating what Ray is saying, but like because the way that magnetic fields are produced by moving charges, you don't really have like just one thing producing a magnetic field. You're never going to have a non-zero divergence. Um, Curl has to do with the tendency of the vector field to go in circles, I believe. It's a little bit tricky though. I have a hard time. I curl I struggle with a bit. It has something to do with the vector field kind of flowing around in circles. But that's kind of the best that I remember offhand. Uh, the name coincidence of circulation. Yeah. No, it's okay, Freddie. It's just a very big question that I think you really need a lot more background to truly understand it. So I would encourage you to do some more studying on vector calculus because Maxwell's equations just aren't going to work very well if you don't know them, or if you don't know some vector calculus. So you don't need to go super intense with it, but I do think you need to know some. Uh, Curl is the rotational motion of divergence. Curl and divergence are completely separate things, but they are related and often both used. Um, okay, so the way that you do this is you basically draw little boxes inside of a vector field. So like the way you solve these equations here is you look for a box to draw um, that lets you evaluate an area where the divergence or curl might not be zero. And so in that one that I talked about, where is it? Okay, I don't know why they're doing that, but um, and the one I was talking about right here, where it's coming from the middle, like divergence of f is not zero, but the curl f is zero because if you draw a little box that looks like this, the field goes with it on one side of the box. The sort of top and bottom are both perpendicular, and therefore don't contribute to the curl. The left side contributes a positive amount because it's going in the same direction, and the right side contributes a negative amount that's the same because it's going in the opposite direction of the field. Would the vector field just be the actual magnetic or electric fields? Yeah, just the actual magnetic or electric fields. Yeah, $10. Um, but yeah, but the trick to do is you draw an oriented box and you figure out what when the field agrees and disagrees with the box, or if it's perpendicular, then it just does zero. I'm not I don't have a very good understanding of this for myself, which is why I'm struggling to give a very good explanation for it. So I'm sorry about that. Um but the basic idea is that curl has something where it's like a source the vectors are coming from or sinking into, and curl has some sort of circulation. Like a whirlpool would have like the most curl, I guess, probably. But yeah, you do ask about the exact curl and divergence like an electric field or a magnetic field. So you could if you just have a stationary point charge, its electric field, well, just look like that. You would say the divergence is positive because you could draw a box like this, and all the vectors are coming out of it. Nothing is going back in. So divergence will be positive. There's no box you... Sorry, this is an oriented box, but it's not really that important here. There is no box you can draw that gives you any sort of like flow. So the curl of that is going to be 0. So that's kind of the best kind of... I'd have to do a lot more thinking before I give a better explanation, but that's kind of like the very quick and dirty. I do want to talk about Zeliak's question about complex numbers. But I hope this helps you a little bit, Freddie. It's you're in AP Physics. You could I need to plug his channel more. You could try Actual Education, aka Dr. Gold. He does dual stream to YouTube. And he's probably a lot better with AP Physics than I am. Let me find his a link to his channel. Yeah, I think he normally should be next on Monday in 2 days. Okay, so Zelex, you want to know about complex numbers. So you want to know the difference between the algebraic form and the trigonometric one. So yeah, it helps to be like as specific as possible with what you want to know about them. But let me give you like, I guess let's like talk about them. So a complex number is some number that looks like a plus ib, where a and b are real numbers. And so this could be 1 plus 2i, negative 5 plus 3i. It could be pi plus the square root of 2 times I. Like any real numbers you want. So whole numbers, fractions, irrational numbers, stuff like that. And we often graph these numbers on what's called the complex plane. I should say complex numbers have what's called a real part and an imaginary part that goes with the I. And so you can treat these like X and Y pairs, where we have a real axis and an imaginary axis. So we could plot 1 plus 2i as 1 to the right on the real axis and 2 up on the imaginary axis, and that will be 1 plus 2i right there. We could plot negative 3 minus 2i, and that will be right here. I probably should have started by saying that I is equal to the square root of negative 1. That's an important bit. And you're generally not allowed to take the square root of a negative number. Or at least in normal math, you're not allowed to take the square root of a negative number. But if you just kind of let the square root of a negative number exist and not say that you've done something wrong, then you unlock the world of complex numbers. And so I would say that the stuff I wrote here is the algebraic form of a complex number. Where it's just a real number plus I times another real number. Now, I was given these points over here with like an x and y pair, but I could have also very well have given an angle with the real axis that we might call theta and a distance r to go out from the origin. And that would be a completely equally valid coordinate system. It's possible you might have learned something like this called polar form, completely separate from, well, not maybe completely separate, but in a context outside of complex numbers. And how do I want to say this? I guess let's use Euler's identity. I think I could probably shortcut straight from the algebraic form to the trig form using triangles. But the way that I'm used to doing it is going through the polar form of a complex number. So let's start with a complex number in algebraic form. Let's go with 1 plus 2i. And then let's convert it into the polar form. This isn't what you asked about, but it's the way that I'm used to get eventually to the trigonometric form. If actually, even before I do an actual example, if algebraic is a plus ib, the polar form is r e to the I theta, where r and theta are the exact things that I set up here. R is distance from the origin, theta is the angle with the real axis. And you can go from this polar form directly to the trigonometric form if you know Euler's identity, which is e to the I theta is equal to cosine theta plus I sine theta. So just taking this identity and plugging it in here, the r stays on the outside, but r cosine theta plus I sine theta. And so if we wanted to now go to our example of 1 plus 2i, the radius, so the distance, if you know maybe like the distance formula for 2 points, it's the square root of x1 minus x2 squared plus y1 minus y2 squared. But if one of your points is the origin, which it is here, that's what we're measuring for r, then the formula becomes just whatever point you're interested in, x squared plus y squared. And so x is basically our real part, and y is our imaginary part. And that'll be the r that we're interested in. So if for 1 plus 2i, r is, I'll do it over here, the square root of 1 squared plus 2 squared, which is root 5. So that's our r. So root 5 times e to the power of I. Now theta, we have to use some trig for. If we have, I wish I made this picture bigger. But if we have a right triangle here, we know from the point 1 plus 2i that the tall side of this right triangle is 2. The short side is 1. We can find the angle with trig. So we know that tangent of that angle theta is equal to opposite 2 over adjacent 1. And we can now take the arctan of each side to find theta. So I probably could have chosen a better point here. Because arctan of 2, I don't know what that is offhand, but we can just keep it as arctan of 2. That's still valid. You could also like plug it into a calculator, but I wish I chose a better example. That's unit circle. You know, let's just get a, what is arctan 2? $63.43 exactly, using a calculator. So we'll use that. Oh, no, 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 no. I don't want to do that in degrees, though. No, that's cursed. I'm sorry. I'm going to keep it as arctan 2. Man, I'm so sorry. I wish I chose a better... You know what? I'm just going to choose a better example, because I really want an angle in radians here. And I wasn't thinking that through when I chose this example. Well, let me just back up. Yeah, let's use 1 plus I. I like Sereno's idea here. Thank you. So the R now is going to be the square root of 1 squared plus 1 squared, so square root 2, times e to the I. Now we'll have theta equals arctan. The pattern is always, your y over x or imaginary over real. So 1 over 1, arctan of just 1 is pi over 4, if you know your unit circle. And so I want a nice clean answer like that. So that's our polar form for the complex number. And now using Euler's identity, we can find the trig form, which is root 2 parentheses cosine of that angle, pi over 4, plus I sine of the same angle, pi over 4. And so that's what I would call the trig form there. The kind of secret here is that if you actually evaluated this cosine and sine, you get right back around to the algebraic form. So it goes in a cycle here. We can actually show that. We have root 2. Cosine of pi over 4 is root 2 over 2. Sine of pi over 4 is root 2 over 2. So root 2 times root 2 is just 2, and 2 over 2 cancels to become 1. So it really does just become 1 plus I again. So I hope that answers your questions about complex numbers. If you like to let me know if you want to hear anything more, or if I confuse you on that, or if there's like some other area that you're curious about too. Awesome. I'm glad to hear it. You know, if I can confuse you more, that should be my line. Yeah. I forget if it was a teacher or professor, but I remember I did have someone who would say like, okay, is that clear as mud? And that was like their line. Spirit 2 e to the pi over 4 is codomain, domain, and the codomain? Oh, is that like a function that converts like the domain is well, no, I don't know. You've had several of those. Polar form is a rotation. Oh, or like are you talking about like like a real number that's right here and like rotating it around? I think I might take a quick bathroom break here, and unless someone asks another question, we'll go back to linear algebra ing maybe. But be right back. We're here. You know, I have no jacket on, but I do have a blanket on my lap still. I don't know if anyone else does that. It's not really cold enough to need a blanket, but like they're just like comfortable. Did I find the null space? Oh, I was partway through finding the null space. So I was letting x4 be 1 because that's our free variable. And the x3 is negative 22. Ugh. So then x2 from that equation, 22 plus 3 is 25. 2 is negative 25 over 2. Oh my god, bro. Now I have to get x1. Twenty-two times 6. 132? I think I actually did something right for once. Kernel much greater than null space. You're not the first person to say that, Emma de Blam, today. I'm saying null space just because I was just watching some linear algebra lectures, and that's the terminology that Strang was using. In linear algebra, another languages use null space transformation, like separate from other subjects, Sereno, or what? One will be a positive number. 1, 64 minus 25. 39. That's my null space. So you introduced the person you were seeing at the time, not anymore. To the weirdness of math language. Like, how so? We could multiply this vector 3 by 2, get something without fractions, but who cares? U plus me equals groovy. Math co-ops totally knock his words into horrifying definitions. Oh, I never thought about that, but I guess so. Like singular. Zero pullback? I never heard of pullback. The only kernel I respect is Colonel Sanders, by the way. That's why I use null space. Co-kernel? Oh my god. That one I haven't heard of. I've heard of coset, so I assume that's related. So what am I doing? It was you gave her metric, class, norm, and measure. Oh yeah, yeah, those are good ones. Limit. Variety. I haven't heard of that one. Ring field group, yeah. Even just the word algebra means something completely different to a mathematician. That's way more complicated than what normal people think for algebra. You have to understand definitions very well to understand why they chose the words. I guess so, yeah. Um, that's true. I hate it when people use calculus to describe just normal math, to be honest. Like, specifically, I remember a lot of people were doing it when Thanos, I think in Infinity War, said it's simple calculus or something. If you have the number of people, or I forget exactly what he said, but he did say it's simple calculus, and everyone started saying things were simple calculus, and calculus has like nothing to do with what he was saying. It was annoying me. Um, so if I wanted to solve ax equals some particular vector, is there a good particular vector to choose? I should be able to choose any one, right? Because I have too many vectors, I should cover all of R3. Let's choose like 1, 2, 2. When we have kids in our class, we form new elements of the group. Would mothers be considered the generators of the group? Projective resolutions greater than kernel. So I think we do need to get the particular solution. Don't we need to do the same row operations to our B vector? So it's a good thing that I noted them up here. So I took row 3 and added 3 of row 1. Wait, really? Oh yeah, I didn't get into reduced row echelon form. I just got into echelon form. So we're only modifying the last one, I guess. We do 2 plus 3 minus 16 minus 11. Yeah. So for the particular solution, you just make your free variable 0. From what I remember. So we say that minus x3 minus 22x4 equal to minus 11. But if we let x4 be 0, then x3 is 11. 2x2 minus 11 equals 2. x2 is 13 over 2. Yep. x1, this is the annoying one. 13 times 5 is 65. Ugh. Why? 66? There should be a trick though. Isn't it 67 over 2? Like these should be symmetric when we do this. If 65 is one less, then the answer should be one more than 66. So 67 over 2, right? Yeah, I like that. So that's our null space solution. Our particulars solution is 67 over 2, 13 over 2, and 11. So the total set, and notably, x particular, it's only that single vector, not linear combinations of that vector. Whereas the null space solution is linear combinations. So the total set of solutions to ax equal this vector is the sum of the particular and the null space. And this forms infinitely many solutions. This, I guess, will be a line that exists in R3 and does not pass through the origin. Ooh, oh my god. Don't look at me. x4 is 0. That's a pretty terrible oversight. Okay. The solutions to ax equals 0, you need to take every linear combination of them because it's equal to 0. We only get one solution, but we do need to take every multiple of it. Whereas if you're equal to something that's not the 0 vector, you do not take every linear combination. So in theory, if you let C be 1, I mean, I might just go to Wolfram Alpha here, but let's go to Wolfram Alpha to verify this answer. Put on a ski mask? Why would I do that? Now I always forget Wolfram Alpha's notation. If I have a 2 and a 1. Okay, so these are rows. One, 5, minus 6, 0. Zero, 2, minus 2, 3. Minus 3, 1, 1, 2. So let's just tell me the null space if I give it. Nullity. That's probably the dimension of the null space. Can I do this? It's that. Okay. Is that... That doesn't match what I have. I can't tell if it's the same. I don't think it's the same. But I can't... That should be a 139, and that... Well, these are negatives, though. Did I do something wrong? Isn't using one for example like cheating? I mean... There's a certain point in math where... like... I feel like you should just be allowed to use a calculator for simple things. Like, I'm trying to test myself on like how to use the null space to find the solutions to a system of equations, and the actual mechanics of reducing a matrix. I feel like I don't like. I'm already solid on those. So I'm going to use a calculator to save work or to check my work. We'll call a combination actually a permutation. Oh, you just mean like, oh, you're back to saying like, yeah, like the difference between math language and normal language. Yeah. Did I make a mistake? So, well, I think Wolfram was giving 2 times what I did, but I may have made a mistake on x2, which would have made my x1 wrong. So let's check that again. Yeah, why did I think that was 25? I never multiplied 22 by 2, I think. So that should be 47. In agreement with Wolfram. And we need to recheck x1. I don't know what you're on about, Snacky. 47 times 5 is an annoying problem. That's 5 times 50 minus 15. So 235? And hey, coleslaw. Okay, so 264 minus 235. 264 minus 235. I need to see it. $29? Okay, now that agrees with Wolfram. So we need to come over here. That doesn't affect the particular solution, thankfully. It just affects this final answer here. How Galois theory works? No, I don't know anything about Galois theory. I'm sorry. For Fermat's theorem? No. I've got a bachelor's. Oop, minus 11. It's a great pseudo inverse right there. Fantastic. I could also do this without a calculator. It's just kind of pointless. um, I'm also just trying to check my answer. 29, 47 over 2, 22. Interesting. So this is just the null space vector. And I think I knew that. I just forgot to put that together. Sorry, I spaced out for a second to be honest there. 6713. Oh, that's very different from what I got. Did I miss something else though? Zero. Oh, I flipped a negative. That -2. The -2 that's here should be over here. Wait. No, it shouldn't. Solve 2x plus 5? You can't solve 2x plus 5. Oh, I mixed up the reduced to echelon form. I see what I did wrong. This needs to be a 2. -5 over 2. There you go. What class are you in, Coleslaw? What is a pseudo inverse is? Oh, I have no clue. 521. Why does this not match? Those numbers are not what I get. Coolidge, what like class are you in? I'm sorry, Coolidge. Coleslaw. I was just reading the Discord. Uh, it does help me post things in chat, so thank you for transferring your question into the YouTube chat too, because I only periodically check my Discord while I'm live. The integral looks like it could be really tricky. I am going to put in Wolfram Alpha first, just to make sure it's nothing too crazy. Okay, good. I just want to make sure there wasn't something super crazy in there. Take a look at this. Just took examples mapping one-dimensional affine spaces to points. Not quite projective geometry. Linear vector subspace with the bias are similar. Okay. So you probably need to do long division on this, but it's worth checking what these factor to. Ooh, the top one doesn't factor, does it? Or does it? Maybe. In case we get a cancellation. Um, how would this one factor? Multiplies to 48, adds to 5. Why can't I think of the factors of 48 right now? Twelve and 4. Yeah, I think it doesn't factor, as Sidus was saying. Oh yes, Snacky is tutoring a violation of academic integrity. Let's do long division. Because I don't think the top factors. So I want to take this thing and we wanted to make the 2x squared cancel the 6x squared. So let's multiply that through by 3. So we get 6x squared minus 9x minus 6. So do you guys know each other or what? Coleslaw, are you actually... Okay, there you go. Negative 5 plus 9 is 4x. 8 minus negative 6 is 14. So then the answer to this long division is 3 plus the remainder over the thing we divided by. Hey, programming. So this integral becomes 3 plus 4x plus 14 through 2x squared minus 3x minus 2 dx. This integral is very annoying. That integral that you put in there, Cytos, also looks annoying. I think I've heard of iShowSpeed. I don't know. I don't think I've watched anything though. Um, how do I want to deal with this thing here? Coleslaw, shut up. People can ask other questions at the same time. So the use of that we want to do here is u equals 2x squared minus 3x minus 2. Du would be 4x minus 3. Okay, you guys are out of here. Go away. Go away. Go away. Hey, Ari the Insane. Okay. Sorry about that. Unfortunately, Michael, trolls on YouTube are way too common, and I think they're all three just trolls. So I've kind of lost my patience for people who are just being rude. Um, so yeah, this is the you said that, and so I'll just keep doing the problem, even though the person who asked it is no longer with us, but no longer in the channel. But that's the use that we want to do. But the issue is that this 4x minus 3 doesn't quite cancel with 4x plus 14. We can kind of force it to match though, because 14 is the same thing as 17 minus 3. Oh yeah, there's some really cool people who are over on YouTube. Unfortunately, it has a way higher percentage of trolls, and I used to give them many second chances, and they just kind of keep saying weird shit. And oh my god. Hey, thanks for making the switch so I can ban you twice. Yeah, Ari. Um, like you can kind of tell people just start saying weird stuff. There we go. They you can just tell by the way they act that they're just going to be trolls, and I don't really get what their goal is, but I've lost my patience. Do you know your first viewer in your YouTube live? No, I can't say I remember programming. All right, maybe I should call you Ready or RC Ready. I don't know. Um, so now this one over here, we can get the dream use sub that we want. Oops. This one over here, probably gonna have to complete the square on. Um, so 2x squared minus 3x minus 2. I'm terrible at completing the square when the leading coefficient isn't 1, so I'm going to factor it out. Deal with it later. Yeah, this is calculus. It's like a calculus like 2 thing, or like a second semester class, I'd say. Oh my gosh. You guys are most definitely trolls. Uh, you are not the first or the last that I've seen. AICE program? I never heard of that, no. Let me Google it. Advanced International Certificate of Education. Um, I have never knowingly looked at a question from one of these, but if you want to put a question in chat, there, like, feel free to. Reviews and engagement, I guess you could call it that. That looks like a pretty difficult integral there, Coconut. Um, Let me finish my thought on this integral that I'm doing, but I can think about that one after. It's going to factor to x minus 3 over 2 squared? X got to be 3 over 4. Yeah, I like that. And then these two combine to minus 25 over 16. Oh, true. We could have done partial fractions, couldn't we? uh. Oh wait. Yeah. Um. Yeah, we should do partial fractions. You're right. I mean, I guess we could have done partial fractions even on that step up there. But I guess this is a simpler partial fractions. I'll do it over here. So yeah, this thing here does factor as Saito says, right? I should verify that. 2x squared, negative 4x plus x. Yeah, okay, that looks good. (17) equals ax minus 2a, 2bx plus b. A plus 2b is 0. It's minus 2b or not 2b. 4b plus b is 17. I'm getting bored of this integral, I'm going to be honest. This is too much work. And the person who asked it is one of the people who I had to ban, so. Ban the problem. They famished. Yeah, I did already put it into Wolfram. I was thinking I could get it for myself, but I just don't feel like doing the rest of it. But spoiler alert, that's what you should get, I guess. Kawuna did ask about a different integral that. Oh yeah, I think I see the technique here. We do need to take advantage of a little trig thing though. And the other reason I want to skip over this so I can get to someone who's actually still here in chat, which is Coconut in YouTube, who is asking about this integral. X to the fifth cosine x cubed minus pi. So, well, actually, I was going to say we need to do some trig identity stuff, but we don't actually have to, do we? I think we can just do a u sub here. Well, it'll be easier with trig. So, what I would do here is say u equals x cubed minus pi. So du is, yeah, I think it's something like that, Cytos. That's what I want to do. But I want to show why this is a little bit difficult first. If we did the u sub that we kind of like want to do off the bat, we would get 1/3 x cubed cosine u du. And the thing is, like, we could get rid of this x cubed by making it a u plus pi cubed. And the fact that it's u plus pi cubed makes it really annoying. Possible, but annoying. So I want to try and simplify this cosine of x cubed minus pi first. To make it simpler, because trig identities should have some kind of nice clean form for that. So yeah, I agree that it should be negative cosine, because if cosine normally looks like this, if we subtract pi from all these values, like this point here gets shifted over here. So it'll be a peak, come down to a valley, come back up, like that. And so yeah, this is just negative cosine. I should be even more specific. In black is just cosine x. In green is cosine of x minus pi. But we've noticed just visually that this also looks exactly like negative cosine if you vertically reflect it. When this one's at a peak, the other one is at a valley. You could also do that, Jed, but that's too much memorization for me. So we can say this integral is equal to negative x to the fifth cosine x cubed dx. And now we can get a simpler u sub. Yeah, we're definitely going to want di integration or tabular integration, but it won't be that bad. So we take u equal to x cubed. Du is then 3x squared dx. Plug it in up here. So this 3 becomes a 1/3. This x squared partially cancels the x to the fifth to give us x cubed. And then this x cubed inside the cosine is u, du. Now we do have an issue where there's still an x after we did our u sub, but we have to remember x cubed is just u. So we can now plug that in. So 1/3, oh, never mind. We don't have to do tabular. I forgot the cubed will go away. Okay, so now we can do this with integration by parts. And of course, I already used u. I hate it when I do that, and I need to do integration by parts. So I'm going to say v and w, I guess. V is equal to something, and dw is equal to something. V will be equal to u. Yeah, we'll make it u. And then dw will be cosine u. du. Take the derivative of v. Take the integral of w. And then it would be uv minus v du, but these are different variable names. Even my sleep deprived mind will understand this later. All right. So this minus 1/3, I didn't include it in the integer part, so I do need to remember to include it on the outside here. And then parentheses. So u sine u minus integral sine u du. Multiply the minus 1/3 in and integrate. Sine integrates to negative cosine. It cancels the negative there, but we get a third negative from the negative 1/3. So it's minus 1/3 cosine u plus c. And now we just unsub. Minus 1/3 x cubed sine x cubed minus 1/3 cosine x cubed plus c. I think that's our answer. So if that helps, coconut, let me know. All right, I'm thinking maybe I didn't get to the bottom of my linear algebra thing, did I? Oh, for the integral? Thank you, Jed. Didn't bother checking it. Wolfram Alpha is not agreeing with my answer to the... Oh, wait. I need to check a bit. Wolfram Alpha might agree with my answer. I need to set c equal to 1 and add these vectors. 67 minus 29. 38. 38 divided by 2 is 19. Uh, 13 minus 47. 34. Negative 34, negative 17. 11 plus negative 22 is negative 11. 0 plus 1 is 1. Does that look like... It sure doesn't look like Wolfram's answer. Can I get it just aria? Nope, doesn't like that. See, what I don't like is that I expect my, well, what do I expect? Wait, maybe this does agree with my answer, and I'm just thinking about it wrong. Wolfram's answer states x3 plus 22x4 is 11. Is that true for my thing? Negative 11 plus 22 is 11. Okay. Negative 17 plus 47 over 2 times 1 is 12. Is that true? 34, 47 minus 34. No, that can't be right. I definitely messed up my particular solution. Um, that should be 22. Because 2x2 minus 2 times x3, and x3 is 11. Um, so that makes x1 hey beginner at stuff. Um, just for my own like studying, I'm trying to solve I didn't really write it out very cleanly, but I invented my own linear algebra problem of solving this matrix is equal to, like, if this is matrix A that I just boxed, I want to solve this equation here using the null space. Um, and so I keep on making small mistakes that are making my answers off. But that's what I'm doing. I'm checking back through my work, trying to spot the errors. I'm nearly there. You just took a language class? Oh, awesome. It's been many years since I took my language class, and I'm trying to remember it and fill in the gaps of things that I didn't learn in that class. So I think I'm still making a mistake though. I should be getting 7 for x1. Oh, because it's equal to 1. Wow. There we go. Okay, so particular solution 7, 12, 11, 0. Okay, so then all the solutions to the system is equal to the sum of the particular and the null space solutions. 7, 12, 11. And so I'm going to do, oops. No one click on that link. That person was marked as a ban evader. And the fact that their very first chat was a shortened link means it's probably some messed up website. I am Fembox. I don't want to. I really hate banning people, but for whatever reason, there's a certain type of troll specifically on YouTube who are just kind of relentless and love to make like alternate accounts and things like that. I don't want it to be a place where it's easy to get banned, but people just find a way to keep on pushing it. So, hey, Papadoria. I do think because we can take any scalar multiple of the null space vector, I'm going to multiply it through by 2 just to make the fractions not fractions. Thank you, Coconut. Finn says something about Justin Bieber jerking off. Well, you go do that. Play. But I don't know why you put that in my chat. I'm sorry, Papa Doria. I don't know what that type of. I assume those are bots on YouTube. I don't know what they're trying to accomplish. I assume at some point they'll link you to an OnlyFans or something. But that one's another common type of YouTube troll. I wish YouTube was less trolly. And it's just. I don't get it. Why are there so many jerks on YouTube? Like, you guys who are here right now are awesome. And people like you are why I keep streaming on YouTube. But I don't get it why there's such a high like percentage of trolls. They kind of want. I'll. I guess so. You don't. It doesn't take much to get me to talk about jerking off, though. They not like us exactly. Two chats entirely different culture. Yeah, Tartar. Um. Okay. Am I finally? I think I finally have the right solutions here. Because this matches with what Wolfram has. If we let the free parameter be 0, that's our particular. And if we let it not be 0, then we get every scalar thing of that. How would I have done this in the past before? Because I think my linear algebra class never talked about the null space. Yeah, I did beginner at stuff. So I think if once I got it into like this form, I believe I would have set up an equation like x1. I keep no, yeah, it is a column of 4 vectors, or a column of 4 vectors. Guys, aren't I great at linear algebra? I think the way I was taught this helps in my linear algebra class is that we'd set up this column vector of the solutions and notice that x1 should be 7 minus 22 over 9 x4. 29 over 2. Right, it's smaller. And so x2 is 12 minus 47 over 2x4. X3 is 11 minus 22 x4, and x4 is just equal to x4. And then you split this up into 2 vectors. And this x4 is just a letter. You could make it any letter you want. And so it, yeah, and this is how we avoided, I don't remember ever learning null space in my linear algebra class. We just kind of did this. Only beginners use calcs. That's, if anything, it should be the opposite. Where when you're just learning something, you should probably avoid calculators. For, oh my gosh. Sorry, that stretch had to happen. Like, you're just learning something, you should do things by hand so you can get used to it. But once you've proven you know how to do something, then just use a calculator and save yourself the work. Experts don't need calcs because they are the expert. I think you'll find experts have solved the same type of question so many times that they can't be bothered to keep on doing it. Python is all you need, Teratar? Yeah. Not bad. Not a bad call. Hmm. All right. I don't want to stream for a ton longer, but maybe we'll do a mechanics question. Maybe we'll wrap things up with that. Oh, not that. You create your own computer algorithm to solve your problem. Does it count as you solving it? I think it depends on the question. In my mind, Territar. Like, well, no, I think the answer is always yes. It just might not be a satisfying solution to me. Oh God, should we try this one here too, or just not two, but this one? Oh, the hard mechanics question. Benlux was saying number 24 here was apparently very difficult. It does look very difficult to me at least. But yeah, I think that like if you use like a computer, if you make an actual algorithm that answers the question, then it is a solution, but it depends how brute forcey it is. If you just completely brute force a question, then it's not a very satisfying solution, I guess. You had to solve the exact problem on a past exam? Oh my god. I mean, we could look at this one. Let's see. Maybe we can see if I'm able to figure this one out. I'm not very good at physics. No, I'm studying it to try to get better at it. I guess I should actually do it up here. I never finished off number 15. I'm not going to do that right now. Okay, so my best advice is imagine rigid rods as really stiff springs? Really? Okay. I mean, my thought, they've already defined theta for us, so oops. I mean, what can we get out of this triangle here? So this is going to be a pi over 2 minus theta, because of how they define theta up there. And why is this energy? Like, I'm making it too simple, but it feels like this is F equals ma. It's not an energy problem in your opinion. Yeah, it's in the energy chapter, but it doesn't seem like it needs it, to be honest. Uh, and so um how am I trying to phrase this? Like the mass is experiencing a force from gravity straight down. We want to split it up into component parallel to the rod and perpendicular to the rod. Um, the normal force should be the tension force of the rod multiplied by sine theta. I think cosine theta. Because when theta is 90, the rod is straight. Well, I mean, it depends. If you're measuring theta from the horizontal, then yeah. Well, I made this pi over 2 theta because the problem, at least in this book, already defines theta as from the vertical. I do agree that like whatever that for, however we want to define theta, that force should be is the normal force is equal to mg cosine theta if we're measuring from the vertical. No, wait. Yes. Yeah. There's vertical and horizontal components of the tension force. Hey, YK Benga, welcome in. Um, this makes perfect sense to me that this should slip. But yeah, like what force is making it actually slip? This is a physics problem that I happen to be looking at right now. Um, that have just kind of been, or like I've been studying some physics. Just kind of because I feel like I should know it. Nerduino, hey, how's it going? I've seen you through raids from Zach or E to the 2y pi. Hope you're doing well. Um, I mean, right now I'm thinking about how, like, what actual force will make like once it gets to some angle, this rod, it's going to slip. What's actually making it slip? I guess it's the weight of the mass. Tension force is not exactly equal to mg. Goes in the direction of the rod. And I dual stream to Twitch and YouTube for anyone who's new here, and I'm looking at YouTube chats from Territory right now. Tension force is equal to mg. I recommend writing out on its own. John Smith, no, I'm not a math teacher. I call myself more of a tutor. Hey, Shivam. He said the horizontal tension force equal to friction 2. Must be equal to each other in order to be static. Let's play this as looping. 1 second. New music. There we go. Okay. Yeah, I guess like the thing that I was trying to do says you're saying mg sine theta. They're measuring theta from the vertical in this problem. Like that's just like a given to us. So I think for that measurement of theta, it's cosine theta. Yeah, the component of gravitational force along the axis of the stick. And that should be the cosine theta that I have here. Would we, like, I just want to set it equal to like, well, no. I guess the force of friction would be mu mg cosine theta, right? And wouldn't just be like the component, we're going to compare it with mg sine theta. I guess that's what's weird to me for the gravitational force. Like I guess I would just want to compare like where. Oh, I mean, is it this simple? Like, I was just worried that too many things are going to cancel, but maybe. Maybe this is okay. The the thing is I assume mu equals 1, or we have to consider mu equals 1, or like more than 1 or less than 1. The tension force cancel out, you don't actually need to solve for it. Okay. Oh yeah, okay. If I were to include the tension forces. Is there what angle? Oh well, rather I guess we're solving for theta, aren't we? The answer depends whether mu is larger or smaller than a particular value. Well, mu is always positive. and non-zero. I'm stuck with the stick. uh I'm missing some nuance here, right? Because I'm worried about this hint that they give. Uh, if mu is small, the stick will slip at a smaller angle. If it's big, the stick will slip at a larger angle. Yeah, okay. That makes sense with how arctan is shaped. To be honest, I was thinking that too, Shibam, that YK Banga is typing things out quick. Hey, Denali Dice, if it was negative, it would be Mewtwo. Ugh. We have Mew, and we have Mewtwo. Perfect. Welcome in. Subman, sorry, but no. You text a lot, that's why, that's fair. Just say arctan mu equals mu. What's your question? Ian? This feels too simple to me. That's why I don't. That's why I'm still hesitating here. Whether mu is smaller or larger than a particular value. I never. I'm missing something here. Mu mg cosine theta. This doesn't depend on L. Does that make sense? I think that makes sense if it's massless. Effectively solve for the critical angle theta should really be an inequality instead. Well, okay, yeah. That's fair enough, Tirtar. I mean, we can check the answer on this. I just feel like I'm going to have a classic... I guess... Well, no, I mean, they're asking when it starts to slip. I think that's equality. Like, I can go and check the answer on this, but, like... This entire textbook has, like... Like... Sorry, I'm having trouble even phrasing my thoughts right now because apparently my brain is hitting a wall 3.5 hours in. But it's a really frequent thing with this book that I think I've solved a problem and it seems really simple. And then I check the answer and I was completely wrong. So that's why I'm hesitating so much. Let's see, those number 24. I'm ready to be heard again. Let's see. $24. Height of the mass. See, they're doing this with energy, which... This isn't the energy chapter. I was so confused on how we would use that, though. Uh... Now, does it give us the same result? Maybe a torque for a moment, the length might be important. I guess there might be a torque for a moment. Oh, wait. Well, that's what we got, though. What? The normal force can't be negative. It's not negative for how we define the problem. Oh my gosh. Today is not a good day for YouTube chat, is it? Okay. Um... So yeah, no, it's never... We're not in danger of being negative. Tangent is positive. I don't get why... I don't get why this... I'm just checking what the book is saying against what we've done here. I'm so confused why they're doing this, like, in this way. Cosine theta is less than 2/3, then 5.97 gives a negative normal force. The condition, force of friction. Cosine theta equals 2/3 the critical condition for n equals 0, as they don't want liftoff. That's a funny way of saying it. Um... Oh my god. I am having such a hard time doing math when I am constantly painting people on YouTube. They always come in waves. Um, Maybe Territory, yeah. I feel like it's they either all come at once or there's no one at all and everyone in chat is being cool. So wait, what's up with this? Assuming that I think I need to read this. I don't get what's wrong with what we've done. That like it evidently leads to this same conclusion here. Um. Oh my god. How many alts are these people going to make? This might be a record for most bans of one day. And so we're assuming they're going after Territar now when Territar's been around the chat for a long time and is one of the people who keeps me coming back to streaming on YouTube. John Reed, I recognize your name. I'm having an issue with people keep on they just continue to make alts to try and get around bans. A solution? Oh, that looks like a chemistry question. It's the formatting of it is a little bit difficult to read too. Yeah, I'm sorry. Test brand account. I'm not sure I can do that question. I just want to find the critical condition for n equals 0. The critical condition for n equals 0? I mean, it's only 0 at like data that we don't care about, as far as I can tell. Yeah, I'm sorry. Test brand. Like, theta equals pi over 2, but we don't care about that. I'm sorry, Famish. I saw that and then I got distracted. You have to use the fact that sign distributes each equation systems of equations. Oh yeah, it is a thing you just have to remember. Yeah, I don't get what the critical condition that you're saying is here, Shibang. Problems in chapter 6 this week for L2, but I more or less solved it. Okay. Yeah, I probably should get on to chapter 6 soon. Um, Momentum, torque, angular momentum, statics. I don't know how far I should even go on this, but it's sort of they're not even mentioning the force way of doing this that I can tell. Denali dice. I've been using this book. It's a very like quick I should say it's a very like quick book about mechanics. That the chapters are very like minimal. Like chapter 2, the actual text is 2 into third pages. It's a problem solving book. So it's more about like the problems are really well chosen, and each of them kind of has something that it can teach you. I've read this person's electricity and magnetism book, and I really liked it, and it got me interested in relearning mechanics too. So I've been going through this one. What the hell? That's not the real Territar? Oh wait, I don't know how to tell who's real. Oh my god. Uh I don't know why Territar is the one who's getting picked on here. Uh can I pull up chat history? Okay, that's okay, that was the real Territar who said, "Oh my god, bro." Okay, there. I got the right one. Okay. I'm so sorry, guys. I'm getting trolled on YouTube, and they're like constantly evolving their tactics, and it's making it hard to just think about the math here. Um, so yeah, I still don't see what I'm saying about the n equals 0 critical condition. I can definitely believe that I'm doing something wrong here. I don't I don't know what it is though. I think I'm gonna have to keep on thinking about that one. Um, I know. I did say I was gonna wrap up with this one. It's not really a satisfying conclusion that I came to. Yeah. All right. I'll hang on for you, Shivam, but I think I'm gonna wrap things up soon. Uh, Oh my god. Tiratar, do you want to be a YouTube mod? I feel bad because presumably they started to pick on you in particular, and you're probably one of the people who's been around on YouTube for the longest. So I feel like you're probably the person who I'd choose first. You can? All right. Okay. Thank you too, Jed. Um, we're gonna mod Teratar as well because this is getting a little ridiculous. You know, oh my God, I need to. That is the real Teratar. Okay. I actually have to check that now that it's the real Teratar. Well, now I don't. But there you go. We have a fresh new YouTube mod. Okay, let's try and actually think about uh this problem if we can. Which much you did will work when the mass come down without any acceleration along the stick. Because the stick is rotating, the mass is accelerating, taking into account the A. Oh. All right. See, now that person's they have made so many alts. Thank you, Teratar. You're off to a great start. It's so weird how they follow the same patterns with the things that they say. Golden ratio wind turbines? I don't think I have. Taking into account the math's accelerating. And ooh, interesting. Okay. I might just like put a pin in this and think about it more later. Oh yeah, I've been hitting the hide user thing. I um Honestly, if there is a ban option, I don't know what it is on YouTube. I thought that was the closest thing that YouTube has to a ban. Um, so this, I guess, is the rotational acceleration. Why is it attached to the normal force? But yeah, Finlux, I was trying to do this only with F equals ma, no energy at all. And it seemed to lead pretty quickly to the mu equals tan theta thing. Um, Benga, I guess we're still trying to figure it out. Hey, Mary. Hope you're doing well. Denali. Okay, shoot. I'm sorry. My mind is in a million different places right now. Let me at least Google the golden ratio wind turbine thing. I'm so sorry. I should have paid more attention to that, but I'm like, um, not like at my greatest right now. Golden ratio wind turbine. Isn't it there's like a couple different shapes that it's taking? Yeah, I guess I haven't heard of it. I don't know if you had a question about it, I can try and figure it out, but I don't know anything about it offhand. Um, boom, 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 boom. Whoa, 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 whoa. Oh my god. There you go. I feel like it's fitting for Territar to get get rid of that person. Because circular motion friction are acting together. Mu n equals mg sine theta. Rotational dynamics. May mass acceleration not referred to cause linear motion. Yeah, I mean, I can definitely see like the golden ratio showing up in a thing like that because people tend to like just use it for a lot of things. If it is somehow like better, that's kind of interesting to know about. Motion and friction are acting together. Um, the simplified equation for or like for the wind turbine thing, I didn't see an equation for that. I would definitely take a look at it though. No, this? Oh. I guess I don't know which simplified equation you mean. UN equals. Oh gosh, there's like three different chats that I'm trying to understand at once right now. Shivam, Benga, and Territar. The radial component of gravity is a function of theta. Velocity is a function of theta prime. You get a differential equation. Okay, there's that approach. And then circular motion and friction are acting together. Instead of doing mu n equals mg sine theta, we use mu n equals ma horizontal. Hmm. Rotational dynamics, MA, is often referred to as the context of linear motion, dealing with rotational motion. Right. Um, the thing is, in this book, we haven't even gone to rotational. We have rotational motion, but not like torque or stuff like that yet. Um, which I the book does say an approach using that stuff, but I feel like there should be a way without having to go to torque. Maybe what Tertar is saying. But like, should it be that the mass times acceleration of the mass? No, that doesn't. I wanted to do like some version of mg sine theta plus mu mg. That doesn't make any sense though. Hey Raven, how's it going? Uh, we're just thinking about this mechanics problem that's at the top here. Uh, as is common with these mechanics problems, I thought I had worked it out. But it's not as simple as I thought. You said that centrifugal force doesn't exist. Yeah, I think it's more of a concept, I guess, or it's an actual thing that's acting on the mass. It has to oh what? Oh my god. Wait, well, let's check the chat history. Wow, yeah, that is an impersonator. There we go. Hey, Sarepe or whatever? I don't know. Thank you. Hey, Magnatical, thank you for the kind words. I hope you're having a good day too. Sorry, Raven. It's this has been a day for me. I'm talking to people in the YouTube chat right now, and the people have taken upon themselves to continuously just make new alt accounts, and are just trying to mess with me and other people in chat. So wait, there's a second imposter. Right now they're pretending to be other people in chat because YouTube you don't have like you can just have the same username and profile picture as other people. Not for much longer, lyrics, but at least until we make some progress on this problem, at least that's what I was planning to wrap up on. Um, they do want to troll me, Benga. Um, You want an impersonator, Raven? Oh, be careful what you wish for. Yeah, the beginners. If I'm sorry that now they're choosing you, but we can always tell who's who based off the chat history, so we should always get the right person. Oh, you're working on Cytos's problem, Fenvox? I saw when Cytos put that. I assumed it would be something terrible. There you go, Raven. You have an impersonator. Yeah, Tartar, let me look at what you just wrote. Mg cosine theta plus tension equals, let me write this somewhere else. Hey, Marin. D theta dt squared times L. Oh, we have two equal signs. MGL. Right now I'm just blindly copying what you're writing here. MGL cosine theta. Yeah, chat. I've been chosen as a subject for some YouTube trolls, unfortunately. So. Do you also keep the Tesseract bouncing on a spring simulation? No. Where was that? $25. Thank you for the follow. Sorry, if you posted that earlier and I missed it, that's my bad. Thank you for the follow as well, Lyrics. So wait, this is a Tesseract bouncing on a spring simulation? Fair enough. It does kind of like settle down, I guess, yeah. Done with Clifford / geometric algebra. Oh, nice. I bet that's like, it looks really simple, but I bet it's really hard to actually do. Cross-parts on in 3D and 7D. Right. Okay, so Teratar set V equal to d theta dt times L in order to rewrite the centripetal force. Oh, okay, and Teratar is writing capital L for clarity, but the problem does define it as small l. So what do these equations mean now? Mg cosine theta plus t. I guess are the forces on the rod. The symbol of clever dodgers and the cross product is specialized version something called the wedge product. I've heard the name wedge product. VGA being vanilla geometric algebra. Wow, yeah, I never heard of that. Kinetic energy on the right hand side is going to rearrange it to get the centripetal force. Okay, so I assume this is F equals ma, where this is centripetal acceleration. MGL minus MGL cosine theta is kinetic energy due to conservation of energy. Oh, right. This is the gravitational potential energy at the very start of the problem. And that's the gravitational potential energy after it's fallen through an angle theta. Is it not 1 minus sine theta? Or L minus? No. Wait. No. Anything about that more. uh meow 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 meow. Space-time algebra, projective, geometric algebra, conformal geometry. Oh my god. I believe it. Lyrics. I've studied a tiny bit of very basic group theory. That's about as far as I've gotten. Uh, yeah, L is the length of the rod in this problem. Why is cosine? Oh, I understand this now. I think. Yeah, yeah. Okay. Yeah, I think I get what's happening here. Oh, really? Lyrics? I thought anytime I hear algebra, I imagine it's like the progression as you do group theory, ring theory, field theory, and then those specific types of algebras are some type of it uses whatever of those components that it needs, plus whatever information from some other like context or something. So to be honest, anytime I hear the word algebra, I assume it's some version of abstract algebra, like a Clifford algebra or something like that. Because it seems like there's a million algebras out there. But like I'm pretty ignorant of higher level math. Space of the quadratic form. Okay. Meant to equate kinetic energy due to conservation of energy equal to the actual kinetic energy. Oh. Okay. That's probably a troll right there. Equals 1/2 m. Uh, d theta dt squared. Right. Thank you, Territor. L squared. Yeah, because these are both kinetic energies. It's just another one of the trolls. For somebody that like saying the problem is deceptively simple, it wasn't anything juicy. You end up getting basic vector e0 squared being either +1, -1, or 0, depending on the definition of vector. Pops out that xy equals -y, so it's anti-commutative. Oh, okay. Hmm. You know, I've hardly studied, I guess, any type of algebra, whether it's linear or abstract or Clifford or something like that, I guess. Um, so Territar, it's like the point of this that we can use the F equals ma equation over here. Like they have they have like a really similar right hand side, F equals ma in energy. So we can equate them in some way. Well, no, that's going to simplify out too easily, right? Abstract algebra sounds fun. It's never been my favorite from the little bit that I know of it. One describes the dynamics, the other describes the tension force. Okay. So y equals x dot y plus x wedge y. Fair enough. Lyrics. Favorite field of math? Differential equations and modeling is my favorite. So this doesn't look like an easy differential equation to solve, though. It's not linear. Oh, is it separable, though? I guess it is. No. Yes? Yeah. Right? Just a nasty integral, though? Okay. I don't know if I want to do a nasty integral right now. PDs? No, I've hardly studied PDs, unfortunately. I want to learn more about them. So you have one scalar, three vectors, three bivectors, one trivector. Trivector pseudoscalar. Oh. No, I never heard of a pseudovector. Or pseudoscalar. My physics is also really basic. um, Comes from a cross product? Okay. Vectors, but also not quite. Okay. Plot with the position versus time plot will be in integral form. I guess so, but this feels like a pretty not ideal path to get the answer here. Um, I know, guys. I think I just want to wrap it up. To be honest, this problem it's complicated. I'm having a hard time thinking. Most problems end once you find a differential equation describing the system. Yeah, I bet most differential equations you get realistically aren't really possible to solve, aside from numerically. Cross product is the wedge product multiplied by the pseudoscalar. Oh my god. That sounds crazy. Lyrics. It's equal to tangent of 0. Or tan theta. I think it seems like there's more to it than that, Banga, but or there's something that you have to consider. But it seems like with F equals ma, we got the fundamental part of it right, but I don't know. I'm kind of done thinking for the day, I think. Or at least for now. Yeah, it's kind of like a reverse pendulum. I guess there's a big difference where there's a friction force involved here. We're at a similar math level. Oh, okay. Yeah, I mean, I have a bachelor's in applied math as my background. It's been a few years though, or it's been probably 6 or 7 years since I graduated, so I'm rusty on a lot of stuff that I learned. I do think I need to wrap it up though, guys. I don't want to do a power series expansion. I want to do like the way that the book wants me to, but I don't feel like doing it right now, or at least in a way that the book has like shown. But I don't know. I think I'm done for the day. So, um, if someone in the force exceeds the frictional force, at some point, yeah, lyrics. Okay, so people who are here on YouTube who are actually cool people who aren't trolling me, a huge thank you. I'm sorry about the trolls who were on YouTube. I'm sorry if you got impersonated or picked on. Hopefully they don't come back. Tiritar, thank you for your being willingness or for your willingness to be a mod and for helping with the problem. Last minute troll. I plan to be back on YouTube on Tuesday. On Twitch, I'm going to look for a raid, but the YouTube stream will get cut off here. So thank you, everyone.